So the question says, the diagram above represents a portion of a failure caliper. What is its reading? What is its reading? So let's now consider this now. For figure 3, main scale. The same way we have solved that of micrometer screw gauge, it's the same way with this. But let's see the approach. Main scale. This is the main scale. This is 6, 6.5, 7, 7.5, 8, 8.5, 9. But we don't need all this. You are taking your measurement from the beginning here, the last line to where you will get to failure scale. That is where you stop. 6. Before you get to failure scale, we have another one, 7. So for the main scale now, we are having 7.0 centimeter. Let me remind you, look at this one now. For failure caliper, the main scale, it can be calculated both in centimeter and millimeter. Take note of that. So we are taking this one in centimeter. So 6, 7. Before you get to the what? Failure scale. 7.0 centimeter. 7.0 centimeter. What about the failure scale? Yes, there is something you call points of coincidence for failure scale. And let me remind you that each of this line is representing 0.01 centimeter. Each of these points, this is 0.01, 0.01, 0.01, 0.01. Whatever you calculate here, you are going to multiply it with 0.01. And we don't want to go deep into that, but just take note of that. Okay? So this is what I'm talking about now. Let's calculate where we have the point of coincidence. What do I mean by the point of coincidence? Look at this. You will see a place where the one on top meets the one at the bottom. Look at this place now. This one on top meets the one at the bottom. Apart from this one, all the other ones, there is nothing like that. This is the point of coincidence. So let's calculate now. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. If you take it from 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 centimeters. But I told you that whatever you get from here, always multiply with 0.01. That means you are going to have 9 times 0.01 centimeter. So when we look at the addition and the result of this one now, which is 9 times 0.01 centimeter, we are going to have 0.09 centimeter. The reading on the failure caliper now will now be the addition of main scale plus failure scale. And if you try to add this one together, you are going to have 7.09 millimeter. 7.09 centimeter. Because we are calculating it in centimeter. But I've told you, it can be calculated in centimeter, it can also be calculated in what? Millimeter. So that is the answer for this now. So that's all about failure caliper and then micrometer screw gauge. Right now, we are moving to another topic, which is motion. Under this topic, we are going to treat something on speed, velocity, acceleration. That is, how do we differentiate between speed, velocity, acceleration. At the same time, we are going to deduce equation of uniformly accelerated motion. Under this topic also, we are going to say something about, we are going to solve problems of motion under gravity. At the same time, we will interpret distance time graph and then velocity time graph. At the same time, we are going to do a computation, or we are going to compute instantaneous velocity and acceleration. We will also establish an expression for the calculation of range, that is under projectile motion, maximum height and time of flight. Those are the things we are going to get in touch with. And at the same time, we are going to solve some questions that involve projectile motion. As time goes on, we are going to touch some other things, but let's start from there first. Now, how do we define motion? I am not here to start from the beginning and begin to tell you this and this and that, because I believe all these things are not new to you. I'm only here to remind you what you have been taught. Motion is the change of position of body with time. Simple. The change of position of the body with time is motion. There are some terms that are associated with the motion of a body, and I will give you those terms: displacements, speed, velocity, acceleration. Can you see that? Distance. All these are the terms. These are the terms. These are the terms you want to consider. Okay? As I have told you, you want to differentiate between speed, velocity, and acceleration. Speed, velocity, acceleration. How do they define speed? Speed is just a distance traveled. The distance traveled per time. That is, speed V is equal to distance over time. As simple as that. And it is measured in meter per seconds, because the unit of distance is meter, the unit of time is seconds. And let me add one more thing to speed. Speed is a scalar quantity. Simple. Let me take velocity. How do we define velocity? Distance traveled in a specified direction. And from that definition, that one is telling us that velocity is a vector quantity. And when you are writing the formula for velocity, you say displacements over time. This one is a vector. This one is a scalar. But both of them, they have the same units. Meter per seconds. Can you see this now? Acceleration. How do we define acceleration? Acceleration A is defined the rate of change of velocity with time. The rate of change of velocity with time. Which means acceleration is, let me say, the rate of change of velocity. In this case, now we are going to have what to call final velocity minus initial velocity over time. Or you can simply say velocity over time. When we say change, if you say change in x, that we are talking about the two different positions on the Cartesian plane. x2 minus s1, y2 minus y1. This one can also be v2 minus v1. But in this case, we are talking in terms of final velocity and initial velocity. So the rate of change of velocity is time. And the unit is meter per second squared. Please take note of that. And acceleration is also a vector quantity. It's also a vector quantity. So those are that is how you can differentiate between speed, velocity, and acceleration. Let's take note of that. For displacement also, displacement is just the distance traveled in a specified direction. Then distance is just the position of the body from, you are taking the development of the body from one point to another point. Especially on the Cartesian plane, we give you the distance. Take note of that. From there, we are going to see the equation of uniformly accelerated motion. That is the equation of a body traveling on a straight line, or object, or a particle traveling on a straight line. We will not waste time on that. The equation